Okay, welcome to Laboratory in Mr. Chalmers' dining room. All right, so I brought all the equipment that I need to go through and do a lab this evening so that you guys will have results to use and calculate, and also get to see the procedure of the lab that we're doing. The history of this lab is Mr. Austin and I, who was another chemistry teacher at the time, spent an entire week working at Red Wing Shoe in the chemistry lab. And it was called Teachers in the Workplace. And essentially what it was is we wanted to see what real life chemists do on a daily basis. So we got to work in their labs at both plants, and it was really very interesting and informative. And at the end of the period, we wrote this lab up, which is posted online, and essentially what we're going to do is we're going to take some of the raw materials that are used in making shoes, and we're going to analyze them, and you're going to practice the skills and the calculations that we've been using. Okay, so this is called a quantitative analysis, meaning that we're going to actually get some numerical data in putting together this lab. Okay, so here's the thing. You have two options. One is to print off all 4 pages, save you a little bit of time. It's not required, but you won't have to go back and forth, and it might make doing the lab a little bit easier for you if you have that option. It's not required, to be real clear on that, so don't worry if you don't have that. Then that's okay. So for preliminary work, what we're going to do is you're going to read this first page, read through the whole procedure, and either print the page or copy the entire data table 1, including this little part right here where I wrote in and sort of started the calculations for you. Okay, so hit the pause right now, read the first page, and get this data table copied one way or the other. Okay, all right, so welcome back. You now have a copy of the data table that we're going to be doing, and you've read through that, and you saw one of the first things was that you are to get a sample of water. Voila, just like magic. I get to pull it right from off screen there. And you're going to record the temperature of the water, and we're going to add hot and cold water. I've already done this for you until it gets right between, so it says 25 plus or minus 1 degree. So that means anywhere from 24 to 26. And as it turns out, since I already wrote the 25 degrees in the calculation, I manipulated this. It was up to about 27, so I put a little bit of cold water in there, and yep, I got her down. This is 25 degree water. So notice when you wrote your density calculation, when you were copying the notes or looking at the copy here, you see that it says D superscripted 25 degrees Celsius. Okay, so density does change slightly with temperature, so it's just good form if you know the temperature to include that. Okay, now it says record the mass of exactly 25 milliliters of water using a pipette. This is a 25 milliliter pipette. It has a pointy end there, and it has a one little line right there, just one line. All right, and that one line, you're going to get that meniscus to fall right on that line. So notice I'm putting the pointy end in the water, and then I'm going to use this thing, which is known as a pipette bulb. Okay, so a pipette bulb is just a little thing you can squeeze. So I squeeze it, put it on the end, and I don't know if you guys will see this or not. See if I can give you a good angle there. You see that level of that water going up. I'm just putting a lower pressure on the top and basically sucking it up into the pipette. Okay, and then once I've done that, then this is going to be hard to show you, but I just kind of, here, I'll just let it drip right on the floor, as I don't have that much extra. You can kind of just roll your finger on this thing, and that level will go down real slowly, and you can get that so it's right on the line. Okay, so there it is. It's right perfectly. That meniscus is right on the line. So I'm just going to put one of these beakers on the scale, tare it so it starts at 0. Okay, so now I've started it at 0, and now I'm just letting this sort of run out on its own. And you probably know already that the density of water is about 1 gram per milliliter, because that's what how those things were defined. So this is going to be really close to 25 milliliters. Okay, so I just let it come out naturally. You'll see there's actually some left in there, and these pipettes are designed for that. So this is trial number 1. So you can now write in the mass for trial 1, where it says mass of water. We're going to write 24.89, and then little g for grams. 24.89 grams. All right. So that is trial number 1. If you want, actually, let's wait and do the calculations. I'll explain that to you later. Let's get the 3 trials done right away here. So here we go. I'll try to speed it up for you a little bit. And what we're doing is, to begin the lab, we're going to need the density of water. So that's essentially what we're doing with these calculations, is getting the density of water. So I'll roll my finger like I showed you before, get that right on there. Now, so sometimes it goes a little past, so it just kind of slipped off there a little bit. There we go. Okay. Now, one of the advantages of using the tare, I left that water in there. I can tare it. Right now it's starting at 0. Okay? So I just bring this over, and this is trial number 2. Okay, you can see that was some water in there to start with, but that's okay because we hit the tare button. That's my dog eating in the background, if you hear that sound. Her leash bangs around on the metal bowl. It's kind of annoying sometimes, to be honest with you. All right, so we have trial number 2. 24.90. 24.90, and again, a little g for gram. So we have mass of water for trial 1 and trial 2. Okay, we are now ready. I got to check the time on this thing. We're about 9 minutes in. Okay, so we are now ready to get our third trial. So up that water comes again. Just keep taking the little pipette bulb off and until it rotates on there. Okay, let the level come down again and boom. Okay, so again, important, hit that tare button so it's right at 0. Boom. Let that go back in there again. So we are, for a third time, figuring out the mass of exactly 25.00 milliliters of water. Okay? So if you know the numbers that exactly, we're going to be able to get a really exact density. I'm going to wait, there's a little drop just hanging in there. You're not supposed to shake it, just let it fall naturally. And last trial. .88 grams. Okay, now at this point, we're going to have a different video for each page of the lab. Okay, so at this point, you can do the calculations, because you see I started that first calculation where it says density at 25 equals mass over volume, which equals blank over 25.00 milliliters. So what you would do is you'd put the 24.89 grams on the top of that line, the one that I filled in. You're going to divide them, and your answer is going to have 4 sig figs. All of these, I can tell by looking at them, the density is going to be slightly less than 1, which is the reality of water. The water that we have in our tap is less than 1. So you'll have 4 significant figures, 0.9 something something something. Okay? So 9 and then 3 more numbers, or 4 numbers to the right of the decimal would be a way of looking at that. And then the units, you can see there's grams on the top, milliliters on the bottom. So your units would be grams per milliliter. So what you're going to do at the end of this video, you're going to finish all the calculations for page 1. Be sure to rewrite it exactly as I did in trial 1. Start with D, capital D, 25 degrees Celsius equals M over V equals, and of course the bottom will always be 25.00 because that was our pipette volume. And you will do the 3 trials. And then you're going to take those 3 trials with 4 sig figs, you're going to add them up, divide by 3, and that will be the average that you will post on the bottom, which again will be 0.9 something 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 grams per little m, capital L. So attention to detail on this. Believe it or not, even having me give the data, I had a bunch of people fail this lab last quarter. I'm not threatening, I'm just saying you gotta follow the format here. Okay, so there's lots of points to be had on that first page. Okay, so this is the end of video for page 1 of the lab, and we will talk about why we needed the density of the water coming up. Okay.